Hey everyone! Today we're going to talk about metallic bonding. So this is going to be a really quick video. If you're in a rush or if you just need to learn something really quickly, this is the perfect video for you. So yeah, without further ado, let's get started. So our main question for this video, our key question, really is how do metal atoms bond together? So we know that metal atoms generally form positive ions only since they typically tend to lose their electrons. So they have a positive charge, they form positive ions, and two positives do not attract to each other. So then how do they bond together? Well, we can explain this using the Sieve electrons model. So the electrons are like drops of water in the ocean. Oops, there we go, ocean. Yeah. So all the atoms in a piece of metal share all their electrons. The electrons are communal. So this model is fairly easy to understand, but we can expand our knowledge of it by using it to explain some of the properties of metal. One of them we can use this model to explain is conductivity. So we know that metals conduct electricity well, and electricity is just the flow of electrons. So pause the video and see if you can try to connect this model and this property of metal and try to explain why metals conduct electricity well using what we learned with this model. I'll just give you a second here. Okay, so metals conduct electricity well because the electrons aren't bound to one specific atom and they can move around freely. In other words, they can flow. So electricity, as we said before, electricity is just the flow of electrons, right? And since these electrons are communal, they're not bounded to any one specific atom, they can flow around freely, and therefore metals conduct electricity well. So we can also use it to explain malleability, and that's the ability for a metal to bend and shift, or like shift its shape kind of, without breaking. So ionic compounds are brittle because they have fixed bonds, but that's not the case in metals because of the Sieve electrons model we were talking about, where the atoms are communal and they flow freely and they can shift around each other without break. And that's why when you bend metals, they don't break because the model is more free compared to an ionic compound in which there are fixed bonds. The last one we're going to talk about today is ductility, and that's just the ability to shape metals, shift it into a wire sort of form, and that's kind of the same explanation as we talked about for malleability. They have because the atoms can shift around each other because of the lack of fixed bonds. We have it's ductile and it can move around, unlike these ionic compounds. And then the very last thing we're going to talk about today is alloys. So electrons of two different metals share electrons with each other. Oh, I think it's supposed to say electrons of two different metals are shared with each other. That's probably what I meant to say. Sorry. What I meant to say was electrons of two different metals are shared with each other when forming alloys. So when you have two metals, take let's say iron and copper, for example, right? You have these two metals, when they were made into an alloy, these electrons of two different metals are shared with each other, and that's how it essentially works when alloys are created. So yeah, hopefully that made sense. Sorry for the little typo I had over here. And I just want to let you know that feel free to leave any comments below if you have questions, or email us. We're happy to help you in any way. Please like and subscribe and comment down below what you would like to see next. And remember, we are always here to help you. So I hope you have a wonderful day, and thank you so much for watching.